Hey everyone, well, welcome back for another deep dive. Today, we're going to be talking about something that's pretty small, but it has the potential to be really huge. And that is tiny crystals that can store hundreds of terabytes of data. That's right, hundreds of terabytes of data on something smaller than your fingertip. That's like 5,000 4K movies. On something the size of your fingernail? That's insane. Our source for this deep dive comes from an article in Live Science. And the title of the article is Quantum-Inspired Storage Can Store hundreds of terabytes of data on a tiny crystal, with plans to make them into much larger disks. So we've come a long way in terms of data storage. We used to have those giant vacuum tubes, then we moved on to transistors, then we had floppy disks, then CDs and DVDs, and now we have these tiny little flash drives and memory cards that can hold gigabytes or even terabytes of data. But this new technology, this crystal technology, this could be a real game changer because it takes us to a whole new level of data storage. We're talking about storing data at the atomic level, using individual atoms to represent ones and zeros. To help us understand how this works, we have an expert in the studio with us today. Welcome. So tell me, how do these data-dense crystals actually work?
Well, it all starts with rare earth elements that are embedded within these crystals. Scientists use lasers to manipulate individual electrons within the crystals. And a trapped electron held in place by a tiny imperfection in the crystal represents a 1. And the absence of a trapped electron represents a 0.
Okay, so it's like, imagine those claw machines that you see at an arcade. Except, instead of trying to win a stuffed animal, we're trying to trap an electron with a laser beam.
Yeah, that's a good analogy.
Yeah.
To write the data, they use a laser with a specific energy level to excite an electron and nudge it into that trapped state, which is R1. And then to read the data, they use another light source to release the electron. And as it returns to its normal state, it releases a burst of light signaling that a 1 was stored there.
That's really clever. So it's like the electron is sending up a little signal flare to say, hey, I'm here.
Yeah.
But I'm curious, does this reading process affect the stored data in any way?
It does. Reading the data does cause it to fade over time. It's similar to how data stored on old cassette tapes would degrade over time. So that's one of the challenges that the researchers are currently working on. They're trying to develop ways to make the data more durable. And one approach they're exploring is manipulating multiple electrons simultaneously to make the data more robust.
Interesting. So they're already thinking about how to improve it. That's good. It reminds me of how CDs store data, using those tiny pits and smooth surfaces. But with this new technology, it's like we're going even smaller. We're manipulating individual electrons within the crystal instead of physical pits. It's pretty amazing. But let's talk about the practical side of things for a moment. Can this technology actually be scaled up to create those larger disks that the article mentions? And what about the cost? Is this going to be something that only megacorporations and research labs can afford?
Well, the good news is that the lasers and optical technology needed to make this work are already well established, and they're relatively affordable. And the crystals themselves are inexpensive to produce. The challenges lie in two main areas. First, sourcing rare earth elements in large enough quantities can be tricky. And second, mass-producing crystals with those precise imperfections that trap the electrons. That needs to be carefully controlled.
I see. So it's not just a matter of having the right ingredients. It's also about perfecting the recipe. But let's say they do figure out how to overcome those challenges. What kind of impact are we talking about?
Well, think about it. If this technology takes off, we could be storing unimaginable amounts of data on devices the size of a grain of rice.
Yeah.
Imagine the implications for everything from medical devices to wearable tech. We're talking about a potential paradigm shift in how we interact with data in every facet of our lives.
A grain of rice holding petabytes of information. That's incredible. But what about the potential downsides? Are there any risks or ethical concerns we need to be thinking about now before this technology becomes widespread?
One area that we need to think carefully about is the longevity of the data. As we discussed, the reading process causes some degradation, so for archival purposes, we need to develop strategies to ensure that the data remains readable over very long periods.
Right, so we need to make sure that our data is safe and secure. But even with those challenges, this technology has the potential to revolutionize the way we live. It's exciting to think about all the possibilities. So what are some concrete examples of how this crystal tech could revolutionize specific fields?
Well, let's start with scientific research. Imagine astronomers being able to store and analyze vastly larger data sets from telescopes, leading to groundbreaking discoveries about the universe. Or consider the field of genomics. With the ability to store and process massive genomic datasets, researchers could unlock new insights into disease prevention and personalized medicine.
Those are some pretty big implications, but I imagine this tech could shake things up beyond the research world. What about everyday applications?
Absolutely. Imagine a world where you could download an entire 4K movie in a matter of seconds. Or think about the possibilities for virtual and augmented reality experiences. With faster data access, these immersive environments could become incredibly realistic and responsive.
Okay, now I'm starting to see the potential ripple effects. From entertainment to healthcare to how we experience the digital world, this tiny crystal could have a massive impact.
It could. And this is just the beginning. As with any emerging technology, it's difficult to predict the full scope of its impact, but one thing is for sure. This is a field worth watching closely.
I agree. It makes you wonder what other seemingly tiny discoveries might be lurking on the horizon, ready to revolutionize our world. But before we get too carried away with future fantasies, let's bring it back down to earth for a minute. What are some of the key hurdles that researchers need to overcome to make this crystal tech a reality for all of us?
As I mentioned earlier, scaling up the manufacturing process while maintaining those precise crystal imperfections is crucial. And of course, securing a sustainable and ethical supply chain for those rare earth elements is essential. And beyond the technical challenges, there are also important questions to address regarding data security and privacy.
Right. We need to make sure that this powerful technology is used responsibly and ethically. So listeners, what are your thoughts? Does this tiny crystal sound like the data storage solution to the future? Are you excited about the possibilities, or do the potential challenges give you pause? We want to hear your take. Stay tuned, because in our next segment, we'll dive even deeper into the potential applications of this mind-blowing technology and explore what it could mean for the future of how we interact with the digital world.
You know, we've been talking about this amazing data storage tech. You know, the one that uses tiny crystals to store crazy amounts of data. Like, just thinking about it, it's mind-blowing that we could one day have, devices smaller than a grain of rice, storing like entire libraries worth of information. But let's kind of like shift gears a little bit here and talk about how this technology could impact something we use every single day, the internet.
Oh yeah, that's a really good point. I mean, the internet as we know it relies on these massive data centers to store and process information. How could this crystal tech change things up for those data centers?
Because just imagine data centers that are like way smaller. Instead of having these giant warehouses full of servers, we could have these super compact facilities that use way less energy and resources.
Yeah, that would be huge for sustainability. And, it could also potentially lead to faster internet speeds and lower costs for, people like you and me.
Exactly. But it's not just about making the internet we have now more efficient. It could lead to a whole bunch of new possibilities.
Like what? Give me an example.
Well, think about the metaverse, which, it's still sort of like this emerging concept. But it relies on a ton of data to create these immersive virtual worlds.
Yeah, and right now, those virtual worlds, they can feel a little bit limited because of, data transfer speeds and storage capacity.
Right. But with this crystal tech, we could see a huge jump forward in how quickly the metaverse develops. Like, just imagine virtual worlds that are so real and so responsive that it's hard to tell the difference between the digital world and the physical world.
Wow, that sounds kind of scary, to be honest. It makes you wonder, like, how that would change how we see the world and how we interact with each other.
Yeah, definitely. It's one of those things that, as this technology develops, we're gonna have to really think about.
Yeah, for sure. So we've talked about like the good stuff, but what about the potential risks? Like, what are the downsides of storing so much data in one place?
Yeah, that's a really important question. When you have like mountains of data stored in one spot, security becomes like the most important thing. Because imagine, like, if someone hacked into a crystal that had like, a country's entire national archive on it, or a company's customer database.
Oh man, that would be a disaster.
It would. That's why, having super strong security measures and encryption is going to be absolutely essential.
Yeah, I can see that. And what about like privacy concerns? Like, who owns all this data and how is it being used?
Yeah, that's another big one. It's not just about keeping the data safe. It's about making sure it's not being used in ways that harm people.
Yeah, like for surveillance or to manipulate people.
Exactly.
Okay, so it seems like this technology is kind of like a double-edged sword.
Yeah, I think that's a good way to put it. It has the potential to do amazing things, but it also has the potential to be really dangerous if it's not used responsibly.
So what can we do to make sure that, this technology is used for good.
I think the first step is to have, open and honest conversations
Right.
about the risks and benefits. And we need to create clear rules and regulations around data storage and access.
Yeah, we need to make sure that everyone has a say in how this technology is developed.
Absolutely. And we also need to invest in research to develop better security measures
Right.
to protect against data breaches and misuse.
Now, this is a complicated issue.
It is, but that's exactly why it's so important to start talking about it now before this technology becomes widespread.
Agreed. Okay, so we've talked about the impact on data centers and the internet, but I'm also curious about how this could change everyday devices, like our phones and laptops.
Yeah, that's a great point. Like imagine smartphones and laptops with so much storage space that it's basically unlimited.
More like deleting photos and videos to free up space.
Exactly. You could have like your
Big
whole digital life
Yeah.
on a device that fits in your pocket.
And with the faster data transfer speeds, think about how fast you could download things.
Yeah. It would completely change how we consume and interact with digital content.
It would. I bet the marketing teams are already coming up with slogans like a universe of data in the palm of your hand.
Uh-huh. Yeah, probably.
But it goes beyond just entertainment, too. Like, think about education.
Right. Students could have access to like
Ye-
these huge libraries of information.
And doctors could access a patient's entire medical history in seconds.
yeah, it could lead to like
Yeah.
more personalized learning experiences
Yeah.
and more effective medical treatments.
Wow. So many possibilities.
There are.
It's really amazing to think that this tiny little crystal could have such a huge impact on so many different parts of our lives.
It is. It really shows you the power of human ingenuity.
So listeners, we've talked about a lot of stuff today about this new data storage tech, the good and the bad, and how important it is to use it responsibly. But now we want to hear from you. What are you most excited about when it comes to these tiny crystals with their massive storage capacity? And what are you worried about? Share your thoughts with us and stay tuned, because in our last segment, we're going to dive into some even more mind-blowing possibilities and explore what this technology could mean for the future of humanity. Okay, so we've talked about shrinking data centers and smartphones with like crazy amounts of storage space and even a metaverse on steroids, all thanks to these tiny crystals. But now I want to get really like out there. You know what I mean? I want to talk about some really wild possibilities, the kind of stuff that sounds like it's straight out of science fiction, but maybe, just maybe, could actually happen someday.
Yeah, let's do it.
Okay, so what if? What if we could use this technology to like back up a human brain?
Whoa, you're talking about like capturing a person's entire consciousness, like all their memories and thoughts and experiences. That would be like the ultimate data storage.
Right. Like imagine if we could preserve someone's consciousness even after they're gone. Or like imagine being able to relive your own memories from like a first-person perspective.
I mean, it would definitely raise some serious ethical and philosophical questions like, what does it even mean to be human if our consciousness can be like digitized and stored on a crystal?
Yeah, it's like something out of a sci-fi movie.
Yeah.
But with this technology, it's starting to feel like it could actually happen.
I mean, we're still a long way off from being able to do something like that. The human brain is incredibly complex, and we're just starting to scratch the surface of how it works.
True, but it's still pretty wild to think about, right?
Absolutely.
Okay, here's another one. What if we could use this technology to communicate with aliens?
Now that's an interesting thought.
Like imagine if we could put a ton of information about humanity on a crystal and send it out into space like a message in a bottle.
It would be like the ultimate cosmic postcard.
And if some alien civilization found it, they could learn all about us.
Of course, there's no guarantee that they'd be able to understand our message, or even if they did, what they would do with that information.
Yeah, it's a long shot, but it's still a pretty cool idea to think about.
It is. It would be like our way of saying, hey, we're here in this vast universe.
So as we explore these possibilities, it's clear that this tiny crystal has the potential to unlock some truly amazing advancements.
It's a good reminder that sometimes the smallest things can have the biggest impact.
And it's up to us to make sure that we use this technology for good.
I couldn't agree more.
Well, listeners, that's about all the time we have for today's deep dive. We've explored the science, the potential applications, and even some far-out possibilities of this incredible technology. And we hope you've enjoyed the journey as we continue to push the boundaries of data storage. Let's remember to do so with both excitement and a sense of responsibility, because the future of data is in our hands. Thanks for listening, and we'll see you next time.